Okay, so let's finish up the discussion on the dynamic range of hearing, which is essentially from your threshold to your uncomfortable level, so the widest range that we can hear. They talk about the range of usable hearing, which is 10 dB below your most comfortable level and about 10 dB below your uncomfortable level. So this is about 40 to 50 dB in range. Basically, it's the usable part where speech falls and that sort of thing. Don't worry too much about that. That's not a really important concept. Okay, so now we're going to talk about how the stimuli are presented. So in the chapter, it talks about the MAP curve and the MAF curve, and we talked a little bit about this early on in the semester. The MAP curve, or minimum audible pressure curve, is essentially where you present the signal through headphones or earphones, okay? And the MAF curve is where you present the sound through the sound field or speakers, okay? Now, one thing you'll notice, this is the really important thing. If you notice here, the MAF curve slopes down a lot, substantially right there. This is due to the natural resonance of the pinna. If you remember, it resonates about, 3,000 hertz approximately for the adult. And so around here, about 3,000 hertz, you see this reduction in the amount of sound pressure level that's needed. And that's because that's where the ear naturally resonates. Okay, remember we talked about warble tones? Warble tones essentially fluctuate in frequency. I sent you that example that fluctuated from like 950 hertz to 1050 hertz, so it had about 100 hertz fluctuation up and down. Go ahead and listen to that again. And so the difference between the MAP and the MAF is essentially that the head and the body play a role in how signals hit the ear, okay, and how they're processed. So there are advantages to having the head and the body alter sound. Now, method of limits, method of adjustment, and method of constant stimuli. We're going to talk about this a little bit later, but what I want you to get now, which is really important, is what the term psychophysical methods. And essentially, psychophysical methods refers to the psychological responses to physical stimuli. So hearing testing is a psychophysical test because you're giving a threshold response. You're pushing a button or raising your hand as the signal gets louder and softer and as it changes in frequency. Okay, so for now, let's not worry about those method of limits, adjustment, and constant stimuli. Let's focus on what psychophysical methods means. Here's an example from the method of constant stimuli. The reason I put this in here, I wanted you to see essentially what we mean by threshold. So as the stimulus level is 15 and it's lower, you get about 0% identification correct. And at some point, about 19 dB, you get about 50% correct. And then at about 21, 22, you get about 100% correct. So we define threshold as at least 50% of the time, okay, that the signal is correctly identified. We can use a yes-no task. We refer to those as a two alternative forced choice task, 2AFC. So it's yes or no. It's male or female. And then we measure the threshold, which is typically around 50 to 75%. We use 50 a lot in audiology. Okay. In the chapter, it talks about listener variables. So what effects do inherent differences between listeners have? Some listeners vary in their predisposition in responding. So we'll talk about that in another chapter. But we call that a response bias. So here's an example. Some people, you put them in the booth and you set them down, you put the headphones on, and you ask them to push the button when they hear the tones. Some people will push the button constantly, right? They're very eager, right? Kids often are eager to please, and so they're listening and they're pushing a button a bunch, even when the sound's not present. And that gives us some false positives, meaning that you get a positive response, but the tone wasn't there. Some people like to wait until it's a certain loudness, right? So they'll wait, okay, I think I hear that, I think maybe, and then they push the button. So for those people, they wait till it's a certain loudness, they have a lot of misses, okay? They miss, they do not push the button or raise their hand when the sound is present, okay? So the listener has a lot of, what's what I'm looking for, has a lot of influence, I guess that's the word, has a lot of influence on how the responses come out. There's also age variation, so presbycusis is that first term bullet point there. That is essentially hearing loss due to aging, okay? As people age, we get high frequency hearing loss first, and that's what's shown in this visual here. So by age, you start to see thresholds at 1,000, 4,000, 8,000 start to decline, okay? So at 60, you could see 1,000 hertz is here, 4,000 hertz is like 15, and then 8,000 hertz maybe 25 or 30, okay? So you start to see a decline in the advanced age that you don't see over here when people are younger, relatively younger. And presbycusis is more prevalent in men than women. They think it's because of noisy jobs historically and that sort of thing. All right. In the chapter, it talks about normal hearing, or 0 dBHL, or audiometric zero. And I know this is a tough concept, okay? But I'm going to try to break this down, make it as simple as I can. 0 dBHL, okay, does not mean the absence of sound, okay? The decibel hearing level, that's what HL stands for. That system was created for audiometers, for hearing testing devices, okay? And so at 0 dBHL, you will have various sound pressure level values, or 0 dB SPL. Okay, so let's put these two together. So this, remember, is the normal human growth function. Not growth function, sorry. The normal human audibility curve, sorry. And remember, at 125, it takes more intensity to be audible. At 250, it takes a little less. 500, a little less. 1,000 less. 2,000 less. And then it starts to increase like this. Okay? So, 0 dBHL is different by frequency. Okay, so let me give you some examples. If we were to use this as an example, this audibility curve, all right, 0 dBHL, let me write this here, I think this will help you. Zero dBHL, okay, I'm not writing all of that out, just put 0 dBHL. For this would equal, what's this for 125? It's like 45. So 45 dB SPL. And again, we'll cover this on Monday, so it'll make sense. Okay, so at 125 hertz on the test equipment, if you set it to 0 dB HL, it's going to equal 45 SPL. Now, what do we do at 1,000 hertz? What's that, about 10? We'll just say. So 1,000 hertz, your 0 value, your 0 dBHL value is equal to 10 dB SPL. All right. So the reason we use an audiometric zero is we need to establish kind of a standard normal hearing level. So what they did was 60, 70 years ago, they had thousands of people get tested. People with normal hearing. And this is what they found. That low frequencies need more intensity, mid frequencies need a little less, and high frequencies need a little bit more as it goes up. Okay? So the point here is that 0 dBHL, that's on an audiometer, which I'm going to show you an audiogram and you'll see that, is different by frequency. Okay? It's not the same level. It's louder for this and less loud for this. Okay? And we'll go over that again, I promise. Okay? But take this, read the chapter. I think that should help. All right, let me erase that. Okay. Again, this is an audiometer, or this is an audiometer, an audiogram. Okay? And it has dBHL along this axis, dB hearing level. So 0 at these frequencies are all different when we look at it in sound pressure level. So in essence, 125, 250, if you had a score of 10 for each, let's say, these would be much louder in dBSPL than these, because remember, these are much easier to hear, these frequencies, than these frequencies. Okay? And again, the audiogram, I think it mentions in the text, but the circles are the right ear, the X's are the left ear. Okay? This is an audiogram and has them separate. Sometimes you see them on one portion of the audiogram. Okay? All right. And again, we're going to go over this, so don't sweat it. This is one of the more challenging topics. Now, two concepts that are important, localization and lateralization. Lateralization is essentially, where did you hear the sound under headphones? Was it in your right ear? Was it in your left ear? That sort of thing. Localization is, where did the sound emanate from? Was it from 0 degree azimuth right in front? Was it from 45? Was it from 90? Was it from 180, 270? So when we talk about localization, we're talking about where the sound is coming from. Okay? And there are a couple cues that we're going to talk about on Monday. One is interaural intensity or level differences. One is interaural timing or phase differences. Okay? These two cues help us localize sounds. Now, I'm going to hold off a little bit from getting very detailed on that now, but memorize, think about the two cues. Interaural intensity, meaning the sound is louder at one ear versus the other. That's one cue. The other cue is interaural timing or phase differences, which means it takes longer, the sound hits one ear before the other ear. Okay? Oops. Then we talk about a cutoff between high and low frequencies, and that's about 1500, which again we'll talk about. But for now, think about what lateralization means, localization means, and then we'll talk about some cues on Monday. So one other concept that I want to go over is the minimum audible angle. It's essentially the smallest angle that you can detect if a sound was coming from like right here versus right here. Okay, so it's called the minimum audible angle. Pretty easy concept. Now the last concept is bone conduction hearing. So if you haven't had 342 yet, you might have had this in 200, but we can hear by air conduction, which is this pathway. And then we can hear by bone conduction, which is this pathway. So it bypasses the external ear. And so what we do as audiologists, we test air conduction versus bone conduction, and that gives us an idea of where the hearing loss is occurring. Okay, so it talks about that in chapter 5 as well, and that's bone conduction hearing. Okay, I'm pretty sure in 200 this was gone over too. So those are the two pathways: air conduction pathway, bone conduction pathway. All right, that's it, and we'll finish this up the next time we meet.